quadratics and use the factorized version to find intercepts and things. Then last lesson we used completing the square to help us find the turning point. And the last method we need to use is the quadratic formula, because some equations we can't factorize. We possibly could use completing the square method, but let's face it, if I want to try and bring a 3 out of this, it's going to make these numbers in here very, very messy to deal with. So sometimes the quadratic formula just makes everything easy. So you should all know how to use it, but let's practice. In question number 1, we just want to use the quadratic formula to solve that quadratic equation. Remember that the a is the number in front of the x squared, and I'll say it again because it did happen in the last test. Do not substitute x's into your quadratic formula. It is only the number in front of. Okay? The a is the 3, the b is the 5, and the c will be equal to the -2. And all we need to do is sub it into that formula, which you do have on your formula sheet. Okay? So let's sub straight into it. X equals minus b, b is 5, so -5. Then we have our plus or minus sign and a big square root sign. B squared is 5 squared minus 4ac. So a is 3 and c is -2. All over 2a, where a is 3. So 2 times 3 on the bottom. Now, it is possible to type all of that into your calculator and get your solutions from there. However, we do often like to have our solution in exact form. So if that happens, what you do is you just type in the numbers underneath the square root sign. So, for example, for this one, I'm just typing in 5 squared minus 4 times 3 times -2, and I get 49. Okay, so I leave everything else, -5 plus or minus square root of 49 over 2 times 3, which is 6. Now, hopefully, you're thinking 49, that's a perfect square. So we can square root that number nicely and get a 7. -5 plus or minus 7 over 6. We can still go further than that because we want to get the two solutions separate, and they do actually come out as nice numbers because the square root sign has gone. It does come out nicely. So to type each one in separately, again on your calculator, you'll type in -5. Let's do the plus first. So plus 7 all over 6, and it gives me 1/3. And then all you have to do is change that minus sign. I'm not going to do it all again because I obviously went back too far. Just change the -5 minus 7 over 6 to get the second solution, which is -2. Okay, so it's straightforward, quadratic formula, subbing stuff in. Question 2, same thing again. Use the quadratic formula to solve this one. It's just not quite as nice an answer because we have the square root's still going to be in there. Let's sub it in. So we have a, b, and c. Subbing into the formula, we have minus b. Now, b is a negative number, so the 2 minuses mean that that's going to become a positive 12 out the front there. Then plus or minus, big square root sign. b is -12, so when I square that, you always remember to put that into brackets. And again, a few people made that mistake on the last test. If you don't put that in brackets, it won't square the minus sign and you will get the wrong number. Then -4 times a, which is 3, times c, which is -2. All over 2 times 3. Like I did last time, I'm going to simplify the third part first. So just typing in the stuff underneath that square root sign, you will get 168. So 12 plus or minus square root of 168 over 6. Now, square root of 168 is not a nice number, so we are going to have to go to a decimal here, or we could leave it exact. Depends on what the question says. If it asks for an exact solution, we would leave it there or try to simplify the surd down possibly. But this one did say that we want 2 decimal places. So at this stage, you would then type those solutions into your calculator. You would go 12 plus square root of 168 over 6, and you would get 4.16 to 2 decimal places. Everyone get that? Or, you actually did it?
Yeah.
Oh, good. Or type in the other one, 12 minus square root of 168 over 6. What did you get? Very good. Negative 0.16. All right. So hopefully that part is fairly straightforward, because now we want to expand on that, obviously, to graph our parabola. So it says in question 3, use the quadratic formula to sketch that equation, which we can tell is a quadratic, a parabola. So like always, we want to find our intercepts. So let's start with when x equals 0. When x equals 0, that means minus x squared is 0, 5x, that's 0 because the x's are zeros, right? So y would be equal to just the 1 on the end, because the other stuff is all 0. Then when I sub in when y equals 0 into that quadratic, I get 0 equals negative x squared plus 5x plus 1. And there is my quadratic that I'm going to have to solve. Now, if the question didn't tell you, you might try to factorize that at this point. And you'd be looking for 2 numbers that, well, actually you got a minus in front of the x squared, so maybe you'd move it all across the other side. But either way, you're looking for factors of 1 that times to give 5, and it's not going to work, is it? So, quadratic formula to try and solve that quadratic. So into our formula, x will be equal to, and I'm going to use it in the same form that it is, so a is going to be the negative 1, b is going to be the 5, and c will be the positive 1 on the end. So substituting in, the formula says minus b, so that means minus 5. Plus or minus square root of b squared, which is 5 squared, minus 4, a, which is negative 1, and c, which is a positive 1, over 2a, which is 2 times negative 1. Okay, all in the quadratic formula. Simplifying that down, we can either leave it in exact form, which is minus 5 plus or minus, just working out underneath that square root sign, you'll get a 29 over a negative 2. However, because we're sketching, that doesn't mean a great deal when you're trying to sketch a graph. It's better to have it as a decimal so you know about where to put things on your graph. So typing that into your calculator, which I think we all know how to do, you will get negative 0.19 or 5.19. I have the x and the y intercepts. What is the other important feature that I need?
Turning point.
Turning point. Max, close your computer, please. Thank you. Both. That's right. You could use the axis of symmetry formula, which is minus b over 2a. But we've already got our 2x intercepts, so the easiest way to find the x value for the turning point is to add them together and divide by 2. So I would go, for the turning point, I'm going to put TP here for turning point. X is going to be equal to the minus 0.19 plus the 5.19 over 2. And that comes out as a very nice 2.5. Once you have found the x value, you still need to find the y value of your turning point. So you sub that back into your original equation for y. So that's going to, I'm going to put it underneath here. Hopefully you've got more room than me. Y equals negative x squared. So that's 2.5 squared. I don't actually need the brackets. Maybe I should leave those out. Plus 5 lots of 2.5. That's the 5x plus the 1 on the end. And that is 7.25. The turning point, I'm just going to write it as a coordinate. X was 2.5 and the y was 7.25. So we've got a little bit of space there on the right to sketch that parabola. Knowing that there was a minus in front of that x squared, you're expecting this parabola to be concave down. The turning point is the y value is positive, so it's all happening above the x-axis. So let's give us plenty of space above, like that. All right, let's start with the x-intercepts. Remember, it doesn't have to be to scale, but it does have to be labelled. So that can be my negative 0.19. And then I have a positive 5.19, which will be over here. My y-intercept was at 1. Let's put that there, 1. And my turning point, so I'm just literally reading off all my results as I go through here. My turning point is at 2.5, which I'm going to try and space that in the middle. 2.5 up to 7.25, which would be really up high here somewhere. And let's label that 2.5, 7.25. Connecting the dots, we get our parabola. Okay. Ready for the next page? So how do we know which method to use? We've learned how to factorize, we've learned how to do completing the square, and now we've been practicing the quadratic formula as well. You're going to tell me the answer, Ben?
B squared minus 4ac.
That's right, the discriminant. The discriminant, this part here, can help us know what we need, which method is going to work for us. Sometimes you'll be looking at a quadratic and you go, I don't know if I can factorize that. I'm not sure what I should be doing here. Sometimes this quick little calculation can tell you what to do. Also, we just like to have questions in our test where I practice getting you to tell me how many solutions a quadratic will have by using this discriminant. So the discriminant is just the fancy name that we give to the part underneath the square root sign. It's the b squared minus 4ac. Now, I think your booklet printed correctly. In here, that shouldn't be a D, it should be a triangle. Did yours print correctly?
Yes.
Wonderful. So triangle in there. So anytime you see a triangle, it is talking about the discriminant. Now, depending on what is happening underneath that square root sign will tell you how many solutions or the types of solutions that you're going to get for your quadratic. If the discriminant, again, it should be a triangle, is less than 0. Now remember, we're talking about the stuff underneath the square root sign. If that is less than 0, we have a negative underneath the square root sign, which doesn't work. And therefore that means we don't get any solutions. There are no zeros. No zeros exist. It's a weird wording. So that means there's no x-intercepts. There is no solutions to that quadratic equation. If the discriminant is equal to 0, okay, so all the stuff underneath my square root sign is equal to 0, that means I'm plus or minusing nothing. So the plus or minus is normally where I get my two solutions from, isn't it? If I now don't have anything to plus or minus, I'm not going to get two solutions, I'm only going to get one. Okay, so that's why if you get 0, discriminant equals 0, there'll be 1 0 or one solution to your quadratic. If the discriminant is greater than 0, and that's what's going to happen most of the time. If it is greater than 0, it means that I get a number underneath this square root sign here, and that is going to mean that there is two solutions to the quadratic. Now, there is another little bit of extra to that I haven't really written down here for you. If that number makes a perfect square when you find it out, it means that you're going to get rational solutions. You're going to get things like whole numbers, or maybe fractions, but nice fractions. Okay? So if it's a perfect square, you're going to get nice solutions, which means there's a good chance that you'll be able to factorize that quadratic. If you get any other number that is not a perfect square, when you get that number here, then it means you've got a surd that is not going to simplify, and you're going to have to use the quadratic formula to get that. Okay? All right. So we're going to just do a little bit of practice here using the discriminant. It says determine the number of solutions to the following quadratic equations using the discriminant. So I just want to write down my formula. Discriminant is equal to b squared minus 4ac. And I'm just going to sub in like I would for the quadratic formula. The a is going to be the 1 that's in front of that x squared. B is 6 and c is 2. So substituting in, b is 6, so it's 6 squared minus 4 times a is 1 and c is 2. Type it in your calculator or do it in your head. We get the answer 28. Okay? The main thing is it less than 0, equal to 0, or greater than 0? This one is greater than 0. If it is greater than 0, that means it has 2 solutions, which means you have 2 x-intercepts if you're going to draw this. Okay? Now that is what we were asked to do for this question. Side note, because that was not a perfect square, if I had to try and solve that quadratic, the quadratic formula would be the best way to go because it's not a perfect square number. It won't factorize nicely. Okay, just a little side. You could possibly use the completing the square. True, yes. Completing the square and quadratic formula, yes, you can use both of those. Part B. I usually find that most people don't use completing the square though unless they're told they have to. It's usually factorize or quadratic formula, usually the preferences that people are most comfortable with. But yes, you would be welcome to use completing the square for it. Part B, let's do it again. The discriminant equals b squared minus 4ac. So the a is the 3, b is minus 5, and c is a 4. Subbing in, b squared is going to be negative 5 squared. Again, I'm using those brackets to make sure that we square that negative sign. Minus 4 times a is 3, and c is 4. What'd you get?
Negative 23.
Correct. So the size of the number is not the key thing here. The main thing we need to get from that is that we got a negative. We got a result that was less than 0. If we have a negative solution, a negative result there, what does that mean for my number of solutions? None. So therefore, no solutions. You would not be able to factorize, complete the square, or use the quadratic formula. There are just no solutions to that quadratic. Which means that would be a parabola that never actually touches the x-axis. It would be all above or all below. So for this one, because there is a positive number in front of that x squared, positive meaning concave up, it's what we call a positive definite parabola because the whole parabola is going to have to be above the x-axis. Okay, another little tip. Part C, one more time, let's find the discriminant. So discriminant equals b squared minus 4ac. A is the minus 2, b is the 3, and c is the negative 7. And subbing in. So I have 3 squared minus 4 times a, which is negative 2, times c, which is negative 7. What did we get this time? Negative 47. Negative again, so less than 0, which means no solutions again. However, our little side note again, this time, when I look at my x squared, I have a negative sign, negative 2 in front of that x squared. That means that parabola is concave down. And it's what I would call a negative definite parabola because it will all be below the x-axis. All right. So that's it. You are doing 3F. Look, this doesn't even look like that many questions. And we are not doing a second one today.